Thank you very much, and welcome to Are You Safe from OWASP number 11, and hopefully you are. So let's get this ball rolling. So first, I'd like to set the scene, and I'm going to speak from the perspective that you're, say, an AppSec. You're running an AppSec program. Maybe you have a product security program because you want to call it that, whatever it is, and you're floating on a sea of software. There is tons of custom built internal pieces of software, and you're just trying to make sense of it, right? This is generally what happens to people that are in an AppSec role. It's kind of a fun and challenging place to be at times. And so you're focused on trying to get those easy, quick wins, right? And you want to get the big things out of the way. So audit is coming to you and talking to you using the OWASP top 10 as kind of their talking points. You've got devs who've taken some OWASP top 10 training. So you're feeling like, hey, I might actually, even though I'm sailing on this little raft with the sail of the OWASP top 10, I may actually be close to land. I may be able to actually start moving forward with my AppSec program, but there's something you missed, right? And that something you missed is OWASP number 11. And what I mean by that is all those things that aren't in the top 10, right? The reason it's called the top 10 is because there's more than 10, right? Kind of academic. So you have to be careful that even though maybe it might make sense to start with the top 10, your program really needs to do more than that. And it needs to be much more holistic. So I stepped back and did a little look at the top 10, and I've been around OWASP for far too long, since 2008. And I've seen many different versions of it over time, and it's evolved obviously and changed over time. And one of the original things with the very first top 10, it was focused on the top 10 vulnerabilities. Later on, they made a change to focus on risks, which I think was a fantastic change. And then as you watch the more current iterations happen, you notice that the risks go to more and more general categories. So the sort of the scope of what's covered by the top 10 has changed over time. And I think that's a very fantastic thing. And it kind of argues to my point that the OWASP top 10 is just the starting place. And even though they've increased the scope over time, it hasn't quite covered all of the possibilities, right? And if you look at this graphic I borrowed from the OWASP website, you'll see those ones in orange are ones that got combined or renamed into larger, broader categories. And then the ones in yellow are ones that were combined with existing or other categories. So you have ones that sort of got compressed into more broad categories and other ones that became different categories. And so the net of this is we have an increasingly broad OWASP top 10 happening, which is fantastic. But even with that top 10, you could still be missing something. And right straight off from the website, this is a pull quote I pulled directly off the OWASP website: globally recognized by developers as the first step towards more secure coding, right? Underline was added by me, but I think a lot of people think it's the ceiling, not the floor. And really, top 10 is the floor. And I was on the website, I was curious, so I poked around in the list of projects, and I found 12 additional variations on the OWASP top 10 theme. The mobile top 10, the API security top 10, those are actually fairly popular. The rest of these, less so. But we could actually have, I realized, a top 10 list of top 10 lists, right? Because we have 13. Like, we could do this. The math works, right? Now, obviously, that's not my intention. But if you look at this, this tells you that humans have this penchant for wanting to look at the top 10 things. I don't know why that's such a thing, but it's just part of our human nature. And you need to fight that part of your human nature and look beyond the top 10. Because sometimes it's the simple things that bite you. So I'm going to tell a little story. I've done a bunch of pen testing in my life. In this one particular case, I was pen testing at a large US insurance company, and I'm testing a web app of theirs. And I'm poking around, and I find the ability to sort and search through some records. And I'm in the States, so I'm going to look for Smith, because that's a common name. So search for last name Smith. I get 6,800 some odd results back. Okay, great. It's got pagination, right? 25, 50, 100 per page. I change it from 25 to 50 per page. I see in my proxy Zap, of course, I see in Zap that, hey, that 50 is actually being sent as a parameter. That's awfully curious. I wonder what happens if I change that 50 to 68 and 100 and change, right? So I do. And what happens is 12 very sweaty minutes of sitting on site at the client, realizing you may have just DOSed their app. Now, luckily, after 12 minutes, I finally got a page back, and I did poke a coworker that was also with me on site, said, hey, go to this URL, make sure it comes up. And he's like, well, it's taken forever, but it's coming up. I'm like, okay. Whew. So this was almost a one request DOS, simply by changing an int to a larger number, right? Failure to validate that data. But this is a simple thing. This isn't any kind of crazy elite attack, right? So you may have done the top 10 and your developers understand those 10 high category risks, but they may not get you all the way there. So I'm going to talk about a couple of holistic approaches at OWASP, and these are OWASP projects that I think are really worth your time to look at, to understand and get a much broader look at the security landscape. So first off, the project is OWASP ASVS, or the Application Security Verification Standard. We know why we call it ASVS, because it's a lot less to say. What does this do? What does this provide? What does this do for you? Well, it gives you a level of rigor in the controls for your application. In other words, if I'm testing, I want to validate that I have the highest level of rigor of controls, I can use ASVS to get that list of the highest level. And there's 3 levels. There's a level 0 as well, which is kind of nothing at all, to 1, 2, and 3. So you can kind of adjust your needs based on that level of rigor, the 1, 2, 3. And then also you can use the same document to provide a list of security requirements for a developer, right? If you're in a middling risk app, maybe you're going to do a level 2 ASVS, either entirely or in a particular category. That listing becomes your list of security requirements for the developer. So why would you want to use this? Well, it's a great metric and a yardstick to measure how rugged and how thorough your security controls are currently, if nothing else, right? You can certainly say, let me look at my app and do I have all these things? You can also use it to test your app to a standard, which is fantastic. You can use it as a guideline to developers who say, okay, you say I'm a high risk app. What does that mean? What do I need to do? Well, do all the level 3 things in ASVS and we're golden, right? So you can actually have a method to talk to the development teams about what they need to do from a security control perspective, as well as if you're contracting third-party testers, ask them, hey, I need you to go out and test this and make sure all the controls listed in, say, level 2 of the ASVS are present and working correctly in my application, right? Now you have a very good rugged test that documents all of the things it does and make sure it meets the standards you need to meet for whatever your security profile is for that particular app. The next one is OWASP SAM, or the Software Assurance Maturity Model. SAM is there to really measure, give you a way to measure and improve over time a security program, right? This is a comprehensive method to measure and then up your game on your security program over time. And it's nice because it's flexible. It's not terribly prescriptive. It's more flexible and allows you to fit your business. Now, why would I want to use that? Well, if nothing else, like I said, it's vendor neutral and it's flexible. So it's a great way to get a gauge on how mature your AppSec or product security program is, which is very useful. But beyond that, just initial measurement, you can take it sort of to the next level and use it as to create a roadmap of how you're going to mature overall or specific areas that are of interest to you or problematic for you, so you can up your game, right? And not only does it give you the ability to create a customized roadmap, but it also gives you demonstratable and measurable ways to show improvement over time. So the people north of you on the org chart can see, hey, not only are we here, but we have plans in the next 3 quarters to get from this lower level to a higher level in this one or many categories, right? So it's a fantastic thing. And then solving the problem. These are probably my 2 favorite highly pragmatic OWASP projects, although I have lots of OWASP projects I like, but the OWASP Proactive Controls and the OWASP Cheat Sheet series. And why I like these is they're developer focused. on writing secure code. You know, let's try to nip this in the bud before we do testing, right? If we can get secure code out of the development side of the house, we're done, right? That's a great place to be. So why would you want to use this? Well, for the proactive controls, it lists the fundamental parts that are needed for any kind of secure application program. So if you're writing any kind of application worth its salt, these are fundamental things that that application should contain. Now, you may need to do more, but this is the baseline. So it's really fantastic for that. And then cheat sheets provide very specific and targeted information about a wide range of security issues, such as you have a developer, you've had a pen test, there's cross-site scripting in their application. They say, how do I fix this cross-site scripting? Of the cross-site scripting cheat sheet, right? Go to that, it'll explain why it's a problem and how to fix it in a very developer-focused sort of one-pager cheat sheet. And the thing that's fantastic about it is that I credit the people who've run this project. They have been really good about gathering the people that really, really care about a small esoteric part of the security domain, like the person who's really into JWTs or JOTs, right? Have that person write that guide. So you get these people that are hyper specialized in one particular area of security, writing a highly developer focused guide. It's really fantastic. Can't say more about good things about that. So let's switch gears really quick. And I work for a company that does API security. So I'm going to dig into the top 10 API security risks a bit. One thing to note with this is interesting. It's security risks. So the API top 10 avoided the whole vulnerability thing. They started with risks, which is a plus. And then if you look at this first half of it, broken object level authorization, broken user level authentication, and then broken functional level authorization. So auth-in and auth-z, those issues are very common in APIs. That's with the software to software or service to service or program to program, whatever you want to call it, API communication model. That's a big weak point. I mean, 3 of the top 10, that kind of tells you something. Excessive data exposure usually occurs when you have a mapping of developers from their data models out to what's sent to the client. A lot of times that's automagical, depending on the framework. And when that automagic sends the entire data model, a lot of developers will assume, well, the client will read off the 3 pieces of the 20 bits of data I sent them and only display that. But if the client is an attacker, you just made that guy's day or gal's day. And then lack of resources and rate limiting is unique to APIs, typically over web applications, although that can also be an issue with web applications. And the idea here is to either stay away from being DOSed or make sure that that API is available to all of your clients, right? If one client can hog all of your resources, that's certainly unfair and not exactly probably how you want your API to handle it. I'm going to take 3 out of here right away. Security misconfiguration, injection, and insufficient logging and monitoring. Those are in the web top 10. They're kind of bog standard thing for any application. They're not really worth digging into. Mass assignment is another issue of that automagical conversion of data coming in down to the data models of the software. If you are only asking for a few pieces of data and I send additional extra data and you don't validate that extra data is A, there and shouldn't be, or B, is there and I ignore it, a lot of frameworks will automatically just submit all of that back down to your data model and it'll be persisted. That's mass assignment. And proper assets management is a very interesting one in that that's really talking about being able to document and understand the whole suite of APIs that are out there and understand which host has which APIs, which endpoints are available, et cetera. Right? So this is really the idea of an inventory, I would say, of APIs. And an interesting addition that really isn't in the OWASP web top 10, but honestly should be. I've done a lot of running of AppSec programs and we never, well, except for one odd use case, I never had a good list. So how are we going to jump the API security shark, right? Let's get into that. So these are all, I'm using the no-name platform, some kind of logos and stuff, but honestly, this is generic advice. I happen to work at No Name, so guess what? I happen to have those graphics handy. So that's what I'm going to show you. But honestly, this is more general advice. I would break it into three major areas. One, what I call API security posture, which is getting an inventory and understanding the data that goes through all of your APIs, all being kind of a critical thing. Generally speaking, this is done by watching the traffic that goes between the clients and the APIs. And in watching that traffic, you get the ability to find misconfigurations and what I would call passive scanning. And those configurations or misconfigurations or vulnerabilities could exist in the source code, in how the network is configured, like an API that should be private is exposed publicly, or in policy. The second sort of pillar is detection and response. So I've got a list of APIs, I understand what data they have. Now I can start looking at how they're being used and understand, or model, honestly, what normal is so I can understand what abnormal is, right? Kind of obvious sort of thing you need to do. And then once you have that understanding of normal, and once you understand where there's aberrant API interactions, you can respond to that, right? You can do some sort of remediation to fix that issue. And then testing, obviously the final pillar. And if you're doing this right, you're doing this as far left as possible, where you can ideally hook this into your CI/CD and have that testing happen early in a pre-production instance of your API before that API rolls into prod. So I've mentioned API inventory. Honestly, I would have almost given my firstborn child for API or just general inventories, and because not only is it nice and necessary to have that list of all of the APIs, but any product security team I've ever been on has been resource constrained by people, right? So if I'm going to have to focus my people where they can make the best use of their time and get the most bang for their buck, I want to have a full view so I can then find out these are the, so many most critical APIs. This is where I'm going to focus my time. These other ones, they're important, but I don't have time to give them the love they need. You can't really do that without an API. And then understanding the data, right, that's coming through your API is also very important. Now, ideally, this would be auto-found, right? You would have a classifier that would watch that traffic and say, oh, there's a first name, there's a serial number, or there's a SSN rather, here's a phone number, whatever kind of data classification you want. So you can then make risk-based decisions based on that, the sensitivity of the data flowing in and out of those APIs. And then detect and respond. So you've got the API inventory, you've got an idea of what's going through those APIs in terms of data, and I know what their usage patterns because I've done some modeling. The easiest way to do it, obviously, is to do some kind of computer modeling of normal. And then once I have that aberration, that abnormal event, what do I do? Well, there's sort of three major things you can do here. You can do a manual response, which is basically, in whatever your console is, show a vulnerability and alert whoever happens to be logged in. Okay, that's not bad. It's not particularly fast. Semi-automated would be something like you see an anomaly and I drop a ticket in a system that's used by humans to go fix it, right? This could be Jira, this could be ServiceNow, this could be a SIM, whatever it is, right? I drop a ticket and now a human has a queued up item to go triage and understand what's going on. Or on the far end of the spectrum, this could be fully automated, right? I could see something outside of the thresholds or the policy or what have you and take a concrete action. I could block that IP, I could de-auth that user. This would usually be with integrations on existing hardware like an API gateway. But the idea is you have sort of three choices when you respond. And then passive and active scanning. So I already talked about passive scanning. That's watching the network traffic and seeing what's going on. And based on what you see, you can make some very safe assumptions about vulnerabilities that may exist. But the flip side of that is active testing. And the ideal case is having the ability to take APIs, connect them by product, right? Or by product or whatever makes sense for your business. Like this is the API that does this unique function for our business. And then test it in a pre-prod instance, ideally with CI/CD, like I said earlier, so that you can get an idea before that thing is exposed to the world or whoever is your client, that it's going out and it's rugged and it's correct. You get reporting and the whole nine. You should anyway with any reasonably good tool. I mean, one interesting thing about APIs is there's a differentiation between like what a web app considers a thing and what an API considers a thing, or I think this distinction needs to happen. So if you take a host plus a path plus a method for an API, that's really what the API is, because example.com/API/users get is very different than example.com API/users post, right? I'm either pulling out user information or I'm adding users to a system. And the security around those two things are very different. And finally, when you start the security journey, obviously when you initiate, you'll start with an inventory. You start to get a handle on the policies around the data that you have and understand what should and shouldn't be there. When you begin to operationalize, you'll do run books and stuff so that if I do see sensitive data in a particular API, I'm going to fire off this ticket to this group, right? You can organize all that. And you'll scale. A lot of times these are done as maybe one of your data centers or one of your cloud providers. Well, let's go ahead and do it across the rest of our cloud providers and then optimize with continual testing. And one interesting thing about APIs is there's a whole bunch of stakeholders at plays here, right? You may have to deal with the product or the API owners, the developers who wrote that API, the network and infrastructure people who make it available to whoever's consuming it. If you have an API gateway, you probably have an API gateway administrator. Obviously, AppSec is going to be involved, and security operations for things like incidents. So thank you. Man, that was rocket fast. If you have any questions, come see us at the booth. NoNameSecurity.com is our website, and we're giving away a free t-shirt if you sat through me blathering for 20 some odd minutes at noname.com/t-shirt. So grab a t-shirt if you like, and I will happily answer any questions that have come in.